Okay, from here we go to hydraulics. Probably not the most exciting topic, but it is probably one of those topics that makes you more valuable once you understand it. Because this is something not a lot of people really understand. And so we're just going to go through the basic premises of the hydraulics, the different functions in the hydraulics of an irrigation system, and find out how water really works. And the first thing is pressure. We have to have a given pressure out there at that sprinkler to make it perform right. Well, to get that to happen, we also have to have enough flow to get out there to go through that nozzle. So the first two things are pressure and flow. So the end result is, if we have a big gun and we want 100 pounds of pressure on it at 80 gallons a minute, we can make sure that happens according to the nozzle size and the pressure that we put on the end of it. Now we're going to have a pump to energize it. So we put a pump on that system to give it pressure. But not only does it have to give you that pressure at the nozzle, it also has to overcome a number of other obstacles along the way. And so one of them is friction. We have to overcome the friction in the main line to get it to a point where it's going to deliver out a lateral to that sprinkler. Now, friction in a main line is constant over length. As long as we keep the same size pipe and run the same flow through it, we're going to have measurable friction loss that is constant right down the pipe. So normally it's going to be somewhere less than 1 pound per square foot per 100 feet of pipe. Usually it'll be less than 1/10 of a pound per square foot per 100 feet of pipe. Now we could have miles of main line on some of these systems. You can take a golf course, you can have a loop main line that'll go 5 miles. And so in 5 miles, that's lots of hundreds of feet. You know, you got 5,280 feet in a mile. That's lots of friction loss that's heading out there. We're losing so much every foot. Incrementally very tiny, but the longer we have to push it, the more we lose over the length of the system. But it's the same. Every foot loses the same as the foot before. So it's additive loss. We just keep losing a little more, a little more, a little more all the way out. When we get to the laterals, then things kind of change. Unless it's a single head lateral, if we're going to a block, like a solid set lateral, we start to shoot water off right away. Or a hand line is probably the most simplistic to think about. You got a sprinkler every 40 feet down the line, and say every sprinkler head was 5 gallons a minute, and you have 30 of them going out there. Well, 30 times 5 is 150 gallons a minute. So coming in, down the main line comes 150 gallons a minute. It starts to go out the lateral. The first pipe has to deliver 150 gallons a minute. The next pipe, only 145. So the friction loss decreases a little bit. The next pipe, 140. Then 135, and so on right down the line. So every pipe has a little less flow in it as it goes out the line. So the friction is pretty high at the front end. By the time you get to the far end, there's virtually no friction loss in the system. So all the friction's lost at the front end and very little at the far end.